Okay, so minimum moves to make an array complementary. Minimum moves to make an array complementary. So given an integer array of 1, 3, and 1, and an integer limit. Sure. In one move, you can replace any integer from nums with another integer between 1 and limit. In one and limit inclusive. The array nums is complementary if for all indices 0, 0 index, nums of I plus its complementary number, that is n minus 1 minus I, is equal to the same number. Okay. For example, the array 1, 2, 3, 4 is complementary because for all indices I, nums of I plus nums of n minus 1 minus I is equal to 5. Hmm. 4 plus 2 is 6, 1 plus 3 is 4. And up to 4, do anything. Okay, so from the example, I like an array that is hash. So for, let me just, you have an array of size n, which is even in length, and the first example is 1, 2, 3, 4, and 3. The sum of this is equal to 4, the sum of this is equal to 6. In one move, you can change nums of 0 to, and the limit is 4. Okay. And I will limit that is 4. Return the minimum number of moves. So I mean the minimum number of moves and number that I'm changing to make nums complementary. Mhm. The array is complementary for all indices equal to the same number. So this first number, I could have converted 1 to 3 as well. No, yes, I could have converted 1 to 3 as well. Hmm. This is 4 and then that is 3. So then we have to convert this and this, the first and the last number to 2. That's what I do. 2 plus 1 is 3, 1 plus 2 is 3, 2 plus 1 is 3. Yeah. N is even. N is even to ensure that we can check for the complementary indexes. Now, what's the difference between both all the numbers? 1 minus 2 is, take a mod, is 1. 2 minus 4 is 2. 4 minus 3 is 1. Huh. Then what is different in the complementary phase? And initially it's like a 4 from the outer ones, and 4 from the outer ones, and then you have 6 in the middle. And then like 4 minus 6 is equal to -2, and mod is the same. Okay. Another example. 1, 2, 2, 1, and the limit is 2. 1, 2, 2, 1, and the limit is 3. It's the sum of all the digits, difference of all the digits. 1 minus 2 is 1 mod. 2 minus 2 is a 0, and 2 minus 1 is a 1. And 1, 2, 1, 2, 1, 2 is 1. The array is 1, 2, 1, 2. What is the difference? The difference is 1 minus 2, that is equal to minus 1, which is equal to 1. 2 minus 1 is just 1. 1 minus 2 is again 1. So difference of all the digits should be same. Difference between all the digits should be same. Hmm. Hmm, hmm, hmm. So I will say that for the complementary pair starting with 0, the difference is hmm, because you cannot compare the pairs because you might be wrong. That's why. I mean, over here I could have converted to both the twos together as well. Hash mark. That's it. Okay, 0 for 0 and it's on the next word. So difference is 1. For 1, it is 0. And for the second, that's just what was the complementary answer again? I plus n minus I. Okay. So store the differences between. Let's now have this array and I'll check what's the difference between zeroth index and first index. And that is one. What is the difference between second and first index and the second index? That is also one. And what is the difference between the mod absolute value? That is also one. So I will have n minus one differences. For n minus one differences, I have to figure out if I can generalize something. Imagine I have this and then I got the same common thing and know the differences of the current index and the next index. Modded. It can I figure out something. Can I binary search on this? Think I can binary search on this. Okay, first let me just create this n minus one modification order that was mentioned in the end. And and then equals to next event where an HT for the last bit. Like n equal to 2 return lines. Maybe not. I don't know. And mod equal to new int size n minus one. So then I equals to 0 I less than an I plus plus. Mod of I is equal to math dot absolute value of the current index minus the I plus 1th index. And print me this print mod. I cannot print it like that. For int I, it's for int I in mod system dot out dot print I plus with a space and just print it and right now just return minus one. I think that's submitted it. Shit. I accidentally submitted it. Compilation of a country. Hmm. Less than n minus 1, that is I less than minus 2. 1 to 1 1. Okay. If I can figure out that, hmm, just find the maximum difference. If 1 to 1 to is a complementary error, then 1 to 1 to 1 to 1 to 5 7 times is also a complementary error. So let me try to go like 1, 2, 1, 2, 2, and 1 and 2. I have a custom input that is, how do you add a custom input? So 1 to 1 to 1, another 1, another 2. What will be the modification on it? Like, hmm. What was the hence? Not this. It's the minimum sum I can get. The sum of this is and well, now I need a empty line here. I missed a semicolon. So minimize the sum. Imagine the target sum should be what would have been the target sum for this number of elements. So I think the mod sum is equal to 0 when mod sum plus equal to mod of 5. If mod of 5 is equal to, so it can be a 0, right? Equal to n minus 1, return 0. And I find mod of n, the n minus 1. Okay. Mod sum equal to n minus 1. Let's set the answer. Okay. No, no, don't make this. That is mod sum. The sum of the max sum of the mod array has to be n minus 1 or complementary. I say max sum plus sum x, max sum plus sum x is equal to n minus 1. I can say that is x is equal to n minus 1 minus max sum. So I have a law that is equal to 0. It's inclusive is 1. I have a phi that is equal to, to the limit. While low is less than equal to high, do I need the difference? The difference would be n minus 1 minus the maximum sum. And the limit shall be 0. Infinite is equal to low plus high divided by if this net is equal to it's less than equal to so moves plus and phi is equal to I think I will just return the moves if net is greater than what am I going to do? What am I going to do? I'm trying to find the nets that ensures this. Okay, so if the net is greater than the distance, just the net uh, high is equal to net minus 1 and h plus is low is equal to net plus 1 and plus I don't know. Cannot find symbol max makes sense. Is it off by 1? Not off by 1. No, I need the exact number in that case. What am I even binary searching on? Why is the output 0? Should this be less than minimize the noise? Could be a one-off error. This is still sum is 2. That's the name. Oh, because it moves it. Okay. What did I change? Oh, that's the equal to. Okay, it's something over here. Okay, my internet is good. Oh, it prints the entire thing. If I have to find, then this has to be equal to. What was that? We start from one. Minimum at minimum until one. Something away. Oh wow, that's annoying. That's annoying. I read the question wrong entirely. नहीं याद है। With one move, change the world. For one pair A and B, the current sum is A plus B. बिल्कुल. To make it equal to some target, S is equal to A plus B. Don't do anything. One move is changing one number can make some S. Two moves otherwise. Use an application report. Okay. Suppose A comma B is possible sums with one move become minimum of A comma B plus one plus maximum of. Oh, the number between this and this. Initially, I assume every pair needs two moves. Then for each pair reduced by one. On the one node range, we do another one at the exact sum. Straight line optimization. For one pair, two moves everywhere, one move on interval, zero at exact sum. Mm-hmm. Difference of two plus equal to two. Each pair contributes intervals, of course. Consider any pair of numbers in nums that satisfies the problem's requirements, where A is the smaller value and B is the larger value. Suppose our goal is to make the sum of every pair equal to C, so A plus B must be equal to C for the entire array for all the pairs. Clearly, the range of C is 3, 2 into limit. At minimum, it can be 1. At maximum, it can be twice of the limit. What? Depending on the value of C, the minimum number of modifications. This is even more confusing. Okay, why and how is it 2 comma 2 into limits? What the hell is the multiplication sign? Oh, shit. For one mirror pair, assume this. Oh, limit plus window, that makes sense. The maximum that I can get for a particular range is the double of the limit. So if the number is telling me that the maximum number is 4, the maximum range that I can target is 8. How many moves are needed to make this pair sum to see how many moves are needed to make this pair of sum to see. Make the pair of sum to see. Okay. It's A plus B is already equal to this. Okay, I don't care about the sum. I only care about making sure that both the numbers. I don't care about the numbers. I only care about the number of changes that I have to make in order to get the sum of A comma B equal to C, not the actual values. That makes some sense. 8 is b is already equal to 7. I don't have to change anything. Case 2 is a single move. Suppose c equals to 9. With a single change, I can make sure binary search can be used here. That makes sense. Okay, that does make sense. Think only in terms of cost. For making 5 plus 2 equal to 7, the cost is 0. For making 4 plus 5 equal to 7 is a cost of 1. And if it's entirely something, but I have to keep in mind the range as well. If the limit is, oh, because now that makes sense. If the limit is equal to 4, like the maximum number, max value of, or value of nums of I, by that logic, the maximum sum that I can get is limit plus limit, right? The minimum I can get is 1 plus 1 because the range is from this bracket 1 to limit. That makes sense. Now the value, the range becomes 1 to limit. These are the, because the range is from 1 to 1 and the minimum, the min is 2 from 1 plus 1. The max is limit 2 times the limit. That is the possible combination of numbers that I can get. And possible, I mean, yeah, the possible combination of possible sum that I can get. Okay, so if I know that it's going to be 2, comma 3, comma 4 for the and everything in between, so 5, 6, 7, and 8, then what I have to do? So I can reach this. The only time I have to change The only time I would need two changes if no. If I have 1, 5 for example, and I need three, then I need to change both. But if I hmm, okay, let me start to code it up. Let me just look at this code and start to type it out. Difference is equal to int of size 2 into limit plus 2. Also, int a is equal to nums of I, int b equals to nums of n minus 1 minus minus I, and low equals to whatever is the minimum between the two, and then a plus 1, because minimum sum has the minimum value inside it has to be from 2 to the minimum value can be 1, but the lowest sum that I can get is 2. I mean, I have to add 1 regardless. And it says a comma b plus the limit. Then the sum is a plus b. Okay. Okay, now difference of 2. Initially assume every single pair of integers is requiring at minimum of 2 nodes. I mean, exactly 2 nodes. Difference of low. Every time I encounter the lower number, every time I encounter this sum plus 1 is plus equals 1. Then I have a difference of high minus high plus 1 plus, plus equals 1. Okay, I kind of lost it. I assumed everything needs 2 moves. Then I said the lower number, the lower value is going negative. But I'm not checking anything. I do some modifications to this array, difference array. Then what I go and answer is equal to integer dot max underscore value. And then the current is equal to 0. And then I'm like for int s is equal to 2, s is less than equal to 2 times the limit s plus plus. Current plus equals to the difference of s for all the indexes. And then the answer is equal to the minimum between the answer and the current. Then I can just get on that answer. I said, okay, you assume everything is true, two moves far, two moves away, like two changes away from being the final sum. Then one move range starts. The low is subtracted. Exact sum needs zero move. Then the difference is 1 plus 1. How the hell does this problem has like a 65% acceptance rate? I don't get it. I still don't get it. It's been a while. When if there's two operations are required, even if the larger number b is changed to the minimum value of one, then the resulting sum of 8% still good. Okay, a and b are the numbers. Makes sense. And these are the limits because the minimum sum can be 2, the maximum can be limit, twice of limit. If my sum is greater than equal to 2 and somehow less than equal to a plus 1, so the first number plus 1. If I'm saying that my minimum number plus 1 is already greater than c, the sum, then I have to change both the numbers. Even if the larger number b is changed to the minimum value 1, the resulting sum a plus 1 is still greater than c. That's why we are ensuring this. That's why there's this a plus 1 here. Okay. So both A and B must be modified. Okay, that does make sense. If I have, if I know my sum is 5, the minimum number that I have is already greater than the sum. I have to change both of them, and that is because is not the second number. Like both the numbers are between 1 and the limit inclusive. If they're between that range, they're always positive. And if A is the minimum number amongst the two, then B is always greater than A. And even in that, then even after that, if the minimum number from both the two is still greater than the sum, I have to change both of them because I cannot get a smaller number by adding something to a number that is already bigger than that. That makes sense. That makes sense. Then we have the second case. Okay, I mean this is obvious. A plus B, no modifications needed. If I have A that is less than the sum, at less than what is C? Like what? C is the equal to the sum, equal to the pair. So when I have the smaller number plus 1 is less than equal to the required sum, and that is less than equal to a plus b, but a plus b is a fixed number, is it not? It's just the sum of both the numbers. I should spend some more time with this, with the editorial. The question is that what am I even storing in the array? What is the reference array even used for them? How is an array that is changing for half the elements of the given array, still ending up giving me my answer. And at every n by 2, at every iteration, Nah, that's fine. I'm not storing the total cost, but how? The index means the target sum C. The value means how many moves are currently needed. So difference of 7 has nothing to do with the index 7 of now. It means what is the total cost of all pairs must sum to 7 question mark. Okay, so if is this actually storing it? Sum is sum is -1, but it's negative. I mean at every I know it's going to be between 2 and 8 for if limit is equal to 4, it's going to be between 2 and 8. Let me just try it and this. That's my iPad. Just try it and this real quick and I might understand. Reading is not that simple. I'm just not at a level where I can just read the editorial and figure it out. It needs time. So the array is 1, 2, 4, 3. The difference array is of the size 2 into limit plus 2. So 2 into limit would be 8 for limit equal to 4. And then plus 2 is 10. So now I have a new array that is of size 10, means 9 indexes. And initially everything is 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let me just type the indexes also. So I think this is 1, 2, 3, 4, 9 indexes. I start by iterating at I. So I is right now here at 1. I is at 1. I take A equal to at I equal to at I equal to 0, index 0 for nums. A equals to nums of I, which is 1, and B equals to 3. C equals to 1 plus 3, that means C is equal to 4. What did ChatGPT tell me? That the index of 7 for the difference array has absolutely nothing to do with the index 7 of nums. The idea is of the difference array is what is the total cost of all the pairs that must sum up to that particular sum that I can possibly get with both the numbers. Okay, I take the max, now I take a low and I take a high. So the low is 1 plus 1, that's 2. The high is it was the maximum plus the limit. So the high is 7, 2 comma 7. Okay. Then what is going to happen? The difference of 2. Why is, I assume that difference of 2 is plus equals to 2. I take difference of 2. I say, okay, you are now 2. Difference of low is -1. So low is 2. That is -1 now. I mean 1. Then I go to the sum, and that is also -1. The sum is 4. Now you are -1. And the difference sum plus 1 is a plus 1. Okay, 5 is now 1 instead of 0. High plus 1 is also 1. High plus 1 is what is high? High is 7. So now 8 is a plus 1. That's how the first iteration ended. The difference array went from all zeros to having 1 at indexes 2 and 5 and 8 and -1 at index 4. Okay, next iteration. Next iteration. At I equals to 1, at I equals to 1, I 0, A becomes 2, B becomes what was B becomes 4, C becomes 2 plus 4, that is 6, low becomes 2 plus 1, that is 3, high becomes 4 plus the limit and limit is 2, so that becomes 8. Hmm. Now let's do the operations. I will again add 2, assuming that it also needs 2 moves. Then I will take low minus and go to the low and go to low and subtract 1. So now 3, index 3 of difference is a minus 1. I will go to the sum. What is the sum? Sum is 6. Now that is minus 1. Sum plus 1, that is 7, is now plus 1. And high plus 1 is a 1. And it's less than n by 2, so everything is done. Now start iterating over here. I start from index 2 and go twice because I have the size of the difference array is twice the limit plus 2, so I just ignore the first two. Just take the current sum and then compare it with the answer. Right now both of them are 0 and answer is maximum value. So I start at I equals to 2. Okay, I almost messed it up. It should have been 3 because I'm adding 2, not changing it to 2. So index of 2 at for the difference array is 2 right now. 3, sorry. It's 3. So I go current difference is the current value of current is 3 and then I compare it with the minimum. So you go from maximum like infinity to 3. I go ahead. I find the minus 1. Now current is 2. I compare, I change my answer to 2. Then go ahead again. It's a minus 1. I compare, so that's now current is now 1. And so is the answer. Algebra plus 1 equals to 2. Same. Minus 1 equal to 1. Same. And then 1 and 1. Answer is 1. Why? Why is this working? Okay, now it's saying, okay, so if I know difference is storing, wait a minute, so difference is storing, it means what is the total cost of all pairs to sum up to 7? It's like ChatGPT, so it's like if I know the maximum sum per pair for any pair cannot exceed twice of the limit. I find out what will it cost me for all the pairs space to reach or to change slash move to all the possible values in the difference in the range. Okay, that does make sense. So now the logic is what have the what have ChatGPT what does ChatGPT have to say? Suppose a comma b is equal to 2 comma 5 and the limit is 6. Target sum is 7. Since the maximum sum any pair can give me is 2 into the limit, the maximum changes. Of course, okay. Although check the now is connecting to also changes in the different side. Think of the target sums on a number line. On a number line. Okay. One pair 2 comma 5. पता नहीं. Cost. Change in cost. Delta cost. What was the total cost of what was the total cost that I calculated on that? That was Oh, because the net cost changes. The net cost changes. Yeah, that is what delta cost meant. The dragon for limit equals to 4 and array is 1, 2, 4, 3. Set of 1, comma 3. Sum is 4. Mm-hmm. Low is equal to 8%, that is 2. Exactly. I is equal to B equals 1, that is 7. Exactly. Makes sense. Okay, I think I'm seeing the bigger picture now. Initially, it would have been -1, +1, +1, +1, +1. Maybe not. That's 4, and then that is 5. Hmm. So between the range 2 and 4, the net change was 1. So between 2 and 3, the net change was 1. The 2 and 5. No, no, that is 1. First, we changed everything. The updates everywhere plus to the next. And change. One change in level 3 and 8. 9, 3, 9. 3 moves total if the target sum is 2. I mean, the send it this. According to the editorial, this is also an option. Um, didn't even read it. Ah, it's fucking dumb. So fucking dumb. Okay, I need to spend some more time with it, but otherwise, I think I understand the general idea of the difference arrays to. So at the end, it's what? It's trying to figure out the cost to reach all the maximum possible sums, all the possible maximum sums, maximum possible sums, however you want to say it. Okay, so I can reach. Takes two moves to reach two. It takes current minus one moves to reach u minus one. Takes some minus one will then add. Therefore, we can use a difference array to maintain how many operations required to reach for each possible target value of C. I can reach, for example, okay, I will look into this a little bit now.